Hello, I'm NASA Curriculum Specialist Rochelle Oblak, here to discuss the Nice Atmosphere lesson from the Weather and Climate Unit. The overall goal for the lesson include the following. Students study atmospheric characteristics of other planets. Students perform a hands-on experiment with the Coriolis effect, and students explore the habitability of planets in an interactive computer simulation. There are two main activities in the lesson. First, students explore planetary atmospheres and the Coriolis effect. This is a hands-on experiment which is part of a much larger educator guide. The second activity is an online exploration known as Astroventure. Students explore science careers and explore the habitability of planets. The objective for the first activity is to create a simulation to model how the Coriolis effect influences weather patterns on a planet with a gaseous atmosphere. The objective for the second activity is to research the characteristics of what makes a planet habitable. For the first activity, you will need a spinning table of some sort. You can use a pottery table, a Lazy Susan, an old record player, a globe, or even a merry-go-round. You also need markers, tape, and paper. The second activity only requires a computer with internet access. You may complete either one of the activities or both.
To set up the equipment, use a rotating table such as this one. You can even make your own spinning tables by purchasing Lazy Susan hardware at a local home improvement store or woodcraft shop. Cover the surface of the rotating structure with paper. Secure the paper to the structure with tape. Next, draw a straight line from the center of the structure to the edge. This line represents the motion of moving objects on a non-rotating surface. Next, one student should slowly spin the turntable in a counterclockwise direction. This is the direction of rotation of the Earth. Using a different colored marker, a second student should draw the same straight line, except this time the turntable is moving out from underneath of the line. Label this line as the counterclockwise line. Place an arrow on the end. And repeat the same procedure with another color of marker. Now you'll move the table in a clockwise direction. Draw an arrow on the end and label this as clockwise. Students then answer a series of questions on their lab sheets. As an alternative, you could perform the experiment for students as a demonstration. Use a globe and some chalk. Ask for a student volunteer and draw a line from the North Pole to the 30-degree latitude mark. Then you will rotate the Earth counterclockwise and ask students to observe what happens. So you can actually make the same line with chalk on the globe. This may also be a good time to discuss wind belts on Earth.
The Coriolis effect lesson is located on page 87 of a larger 223-page Planetary Geology Educator Guide. Read the introduction together or individually. Instructor notes give background on the Coriolis effect. Assign students to groups of 2 if you have enough materials for every student group. You may also complete the activity as a demonstration. The student sheet includes an introduction that states the purpose of the experiment. By tracing an object as it moves across the surface of a rotating and a non-rotating model, students demonstrate the true and apparent motions of objects as they move across the Earth. Next, students examine wind streaks on Mars. An image in the lesson shows bright rays from craters. Have students trace over the rays while being very precise. I will show you in an enlarged example in the next section.
This is my image of Mars. Selecting the brightest areas, I trace rays on this image. It is important to note that this is the southern hemisphere of Mars. The winds here originate from the north. You can see that the overall direction of the curvature is to the left, meaning that Mars does indeed rotate and have a Coriolis effect. If you turn the image around and imagine standing at the point of origin of the winds, it is easier to see the deflection to the left. In other words, north for myself is pointing in this direction. I am here, I am standing at the point of origin of the winds, and they are heading to my left. This can be a point of confusion for students because the tracings seem to curve to the right when viewed face on.
Activity 2 is Astroventure. Astroventure is an educational, interactive, multimedia web environment highlighting NASA careers and astrobiology research. These are in the areas of astronomy, geology, biology, and atmospheric science. Students in grades 5 through 8 are transported to the future, where they role-play NASA occupations and use scientific inquiry as they search for and build a planet with the necessary characteristics for human habitation. The first thing a teacher should do is download the Educator Guide. Select the Teachers and Parents menu option. Scroll to the Educator Guide link. An Adobe PDF file will download. You will find a student journal. Also in the guide are assessment ideas and rubrics. Once students begin, they can read career fact sheets. Students can even play with career trading cards. The main activity includes a training mission and an exploration mission. Students access various parameters in an interactive mission control room. Students choose a career role, formulate hypotheses, access mission control, analyze data, and draw conclusions about the habitability of a planet. Students then input their own hypotheses. Quizzes are presented along the way. Students can design a planet once they learn the material. For NASA's Summer of Innovation, I'm Rochelle O'Black, and thank you for joining me as we explore together.